Alright, question 4. A helicopter flies horizontally over flat level ground at a height of 2.88 kilometers at a speed of 285 meters per second. It releases a package of medical supplies for a group of people on the ground. How far does the package travel horizontally between its release and the impact on the ground? Okay. So we're going to have helicopter. Okay. It releases a package off of here. It is traveling horizontally across the ground. If it is traveling at a speed of 285 meters per second, the package will begin free fall and it'll land on the ground somewhere over here. Their question is, how far horizontally does the between its release and the impact on the ground does that occur? So we're looking for a delta x. We know that this is 2.88 kilometers high, and that's all that it gives. So this is a two-dimensional, so we're going to want to go ahead and write out our x's and our y's. Okay, so I'll have the change in x, the initial and final velocity, acceleration, and time for both. Okay, now this is the x that I'm looking for. Okay, if we understood the problem, this is the x I'm looking for here. Initial velocity in the x direction, well, that's going to be the velocity of the helicopter. Final velocity in this direction is, again, the velocity of the helicopter. Acceleration in the x direction is 0. It doesn't state that the helicopter increased speed whatsoever. So we've got three things. We're trying to find x. If you go ahead and use these three things in the kinematic equations, you will just go around and round in circles, and you'll realize why. That even though you have 3 bits of information, it's still not useful. It doesn't give you anything new out of it. When that happens, it means we need to go over to the y side and solve for some other things. Okay. On the y side, the change in height, it fell from here to here, so it went down 2.88 kilometers. But I don't want kilometers, I want meters. So I'm going to go ahead and convert that into meters. The initial velocity in the y direction, it says that a package was released. It wasn't thrown down or anything like that. It was just allowed to drop. So it's a free fall. So 0. Final velocity, no idea. But I do know the acceleration, negative 9.8, because that gravity is being affected only in the y direction. From there, we can go ahead and we can solve for t. We'll solve for t using our equation that does not involve VF. That's the thing we don't care about. And that will give us this equation. Okay, so I have the change in y, negative 2.880. The v initial is 0, plus 1/2 of a negative 9.8 t squared. So now I want to solve for t squared. So I want to take this 1/2 of negative 9.8, which is negative 4.9, and divide it to the other side. That'll cancel out the negatives, and it'll give us a value for t squared. Then, after we have a value for t squared, we want to take a square root of that to get the value for t. Okay, so let's go ahead and take 2.880, divide it by the 4.9, because remember the negatives have canceled. That gives us 587. Now if we take a square root of that answer, we'll get that t is equal to 24.2 seconds. Okay, so that actually goes into both, because time moves the same whether you're in the x or the y. Time is the same there. And now we have enough information where we can figure out what our delta x is. So for delta x, second equation won't work because that doesn't involve time. We need something that does involve time. So let's go ahead and take, I guess it's going to have to be the third equation. This equation again, but for over here. This time though, we're going to solve for the change in x. So let's put that here. Change in x is equal to VIT plus 1/2 AT squared. Change in x then is equal to 285 times our time of 24.2, and then 1/2 AT squared. The a is 0, so it's going to end up being 0 here anyway. Okay. So if we do that computation, 285, we end up that the change in x is going to be equal to 600, and we're going to go ahead, 6909 meters is the change in x. Okay, that one was a bit of work, but we got there. Change in x, 6909 meters. There is a part B to this, but it's multiple choice. If the pilot continues to fly the helicopter at the same height and trajectory, where will the plane be when the package hits the ground? Okay, so where is the helicopter going to be when that package hits the ground? Okay. Well, this one is just a bit of a thinker. It's a conceptual, right? You have to determine, is it going to be ahead of the package, behind the package, or directly above the package? Okay. Let's see. For it to be ahead of the package would mean that the speed in the x direction of the package would have to be faster than the helicopter. Or the helicopter would have to be faster than the package. Okay. So the helicopter is moving forward at a speed of 285. Our package is moving forward at a speed of 285. All right, so there's our answer right there. This is moving at the exact same speed as this package for the x direction. So if it moves 1 second in the x direction, it's moved 285 meters. If it moves 1 second, the package moves 1 second, it also moves 285. So it is neither ahead nor behind, but instead directly above the package. Directly above the package. Real life, we don't see it exactly that way because there's a lot of air resistance and other factors that take into place. But in an ideal situation, we would be directly above the package.